In this video, we are going to cover the LLD for this Minesweeper game. Let's first try to understand what is this Minesweeper game. So if you see in this picture, in the Minesweeper game, we have a kind of a board which contains multiple cells. Each cell can be either a space like this one, or it can be a number like this one, or it can be even a flag. Or there is one more kind of a cell in this game, which is mine cell. So the what we have to do in this game is initially all these cells on the board are not shown. You basically pick the cells which you want to uncover, and that's how the game goes on. You decide which cells to uncover, and that's how you get the scores. If you pick a cell which contains a mine, then the game is over. So the point here in this game is to uncover all the cells without uncovering any of the mine cell. If you uncover any of the mine cell, then you are done. Apart from mine cell, there is a kind of an empty cell in this board, and there are number cell, and other one is the flex cell. So the number cell is nothing. That number represents, say that, hey, how many mines are there around that particular cell. Just a It just tells that, hey, these are the number of mines which are around me, adjacent, the nearest adjacent, the basically the closest adjacent it have. So the value can be from 1 to 8, basically, because every cell can have minimum 1 adjacent, and maximum it can only have 8 adjacent. The other cell type is this flag cell. This flag is nothing. It is put on by the, basically it is used by the players. It is helping the players to think that when they are analyzing the entire board, if they think that they are suspicious about any cell, they are thinking, hey, this can be a flagged cell. So they mark that particular cell with a flag. This is just for their helping out them to decide which cell they do not need to focus on. So that is just for that purpose. At the end of the game, they need to make sure they are uncovering all those cells which are not mine, and that's the only way to basically win the game. Okay, now let's first start covering the feature requirements. Basic thing which we have is the game board initialization. We should be able to initialize the board with the number of the columns and the row. And in the board, the mines should be placed randomly, and it should not be like, see, you can say, hey, we just need to randomly place the mine, but you also need to make sure that you are not placing the mine in such a way that no one can win the game, that this game is cannot be win in any way. If you are like putting I mean, you just need to make sure that you are not clustering all the mines together. Okay, so that is what is really we need to make sure that we are not doing that while we are doing the board initialization, while we are preparing the board for the users. Another thing is, as we have discussed, we have user interaction. There are two kind of things here. One is user can pick the cell to reveal that cell or to uncover it, and other interaction is either they can flag or unflag any of the suspected mine if they think that, hey, this cell can be a mine. Game logic, basically just a basic calculation where who is win, basically about the win and loss. If a mine is revealed, then what to do? If a known mines are revealed, then what to do? All those we need to write all those logics, and the logic, let's say, reveal all the adjacent known mine cells if an empty cell is selected. So that is what is also another extra rule in this game, that if you have picked a cell which is not a mine cell, then you will reveal all the non-mine cells if empty cells is selected. For just to explain you, if you select any empty cell, then all those cells which are surrounding to that cell, and if they are not mine cell, they all will be revealed. They all will be revealed to you that, hey, these are the numbers on that cell. So that is the one more thing. Display basic things which we normally do, just to display the updates to the users on the board after every move, making sure that they are whatever the moves they are taking, they are visible to them on the board. The patterns which we are going to use here, singleton pattern, to again manage the instance of the game controller, to making sure that we are only having the instance to the we are only having single instance to the game controller, so everything is centralized into through one flow. Other thing is factory pattern. You must have already got it. We are using factory pattern to create these cells. It can be mine cell, it can be some other kind of cell. So we are using this factory pattern for creating these type of cell. One is mine, another one is empty, or it can be some number cell also, which we have just discussed. Observer pattern, again, we have discussed this already in many of the videos, that we are going to use the observer pattern whenever there is any update in the game and we want to notify to someone. So in our case, it should be board, and the players, basically whosoever is watching the game. So whenever there is an update, for example, if a user have revealed any cell, so we need to make sure that we are re-rendering the board for the users so they can see, as we have mentioned here in this one as well, to update the display after any change in the game state. Command pattern again, so we are having two, three kinds of command here. One is reveal cell. Basically, when user give the input of reveal, we are going to use the command pattern for that. And similarly for the flag and unflag also, because these are the command. I mean, we want to encapsulate all the logic which is related to the processing or the transaction for that particular action. Strategy pattern is we are using the strategy pattern to handle different algorithms for revealing the cell. So whenever, as we have discussed here in the rules, so we need to reveal all the known adjacent, we need to reveal all the adjacent known mine cells. So for this one, we can use strategy pattern, like what algorithm we want to use to, do we want to use BFS, DFS, like multiple algorithms you can think of. I feel there is one more place where you can use the strategy pattern. I'm not sure. I think we have not mentioned in the doc, but I don't remember now. In this one, basically, ensuring that mines are placed randomly without clustering too many in one's area. So for this also we can have multiple algorithms for placement of the mines. While we are doing the board initialization, we can have multiple ways of placing the mines. We can have multiple algorithms, or maybe we can even use multiple algorithms like machine learning algorithm, AI algorithms, and all those things. So I think there here also we can use the strategy pattern. Although I'm not mentioned it here, but I feel there also we can use the strategy pattern. Okay. So the algorithms involved here, one is basically random mind placement, as I was just talking. We will be using the algorithms to place the mines randomly, but making sure that there is one more thing in the game actually. So if you see at the top, there is something called beginner, intermediate, and expert. So the algorithm which we are going to use to place the mines on the board should be based on the difficulty level of the game. Okay, so it should not be like basically we are just um, using the algorithm randomly. I mean, based on the difficulty level, we need to make sure that we are initializing the board with that mindset, with that basically thinking that hey, this is an intermediate board or this is an expert board. So we need to make sure we are really making this board game a hard game. So we need to place maybe more mines, or maybe we need to cluster the mines more together to make it more hard and all those things. So that's why I feel that yeah, definitely now it make more sense to have the strategy pattern for placing the mindset. Flood fill algorithm, which I was saying that since whenever you click on an empty cell, for example here, whenever you click on any empty cell, for example in this animation you will see here, see, we clicked on any empty cell and all the adjacent cells which were not mines, they got revealed. So for that, for revealing those things, you can use this flood fill algorithm. Okay. Now let's come to the code part. Um, this is Minesweeper code. So here now we will start going through all the classes and the code, and let's see. Okay, here we are having this. Let's first see the um, class diagram here. Okay, I think you now it should be more clear. So here, this is the main class where we are kind of entirely bundling all the classes and using it to create a final game. Basically to showcase you how we can use the entire design. This is the cell factory which we have already discussed to design to create the cells for the mines and the empty cells, or maybe the number cells also. This command and flag. So here we, as we have discussed, we are going to use the command pattern to create two kind of command, either reveal cell command or it is flag cell command. Okay. Now we are using this observer command on the game view here. Basically, just to clear it here. Okay, let's go to the game view later on. Let's first see this one. Okay, here cell, mine cell, and empty cell. I think we have already, yeah. So here as we were discussing that we will be using the different types of cells. So here you can see we have created a cell interface, and then we are having a different kind of cell, mine cell and empty cell, which is actually used here in this factory pattern. Okay. This is here we are using the strategy pattern basically. For now, we have only implemented the flood fill strategy. for revealing the known adjacent cell when you click on the empty cell. Okay, you can implement more strategies if you have a better way of unrevealing the things. If let's say tomorrow we use the bigger board sizes, then it will make more. It will be more better because as you know, some algorithms may work good for the lesser inputs, and some algorithms will really work good for the bigger inputs. So based on that, you can decide what algorithm to choose for that particular board size. Okay, so this is the game board class which we are actually having. This is containing the existing state of the board. Again, we are using the observer pattern here. Whenever there is an update, we notify the players, and basically wherever we want to notify. For example, here we are having this game view. This game view class we are actually using to show the current status of the board, or you can even say kind of rendering the board on the screen. Okay, you can say it that way also. So yeah. Game control, as we have discussed in last few videos, whenever you see the self association, it always like that, hey, we are using a singleton pattern here. So we are using singleton pattern, this game controller class, which is going to provide us which is making sure that we are having the single instance of the entire game board initialization. Okay. I think we have covered, yeah, everything, nothing is left on the front. Yeah, I think let's directly now go to the code. Okay, let's go to the cell part first. So as I was saying, we have created a abstract class. Okay, I think I messed up when it was not an interface class which we have implemented. We have implemented this cell class. Okay, which is having this is revealed and is flagged. So what we are going to do, what we have actually done is for creating the mind cells from this abstract class, we have just made it this way. That hey, initialize that flag to true, and that's how we are setting that hey, this is a mind cell. And for empty cell, let's go here. Yeah, we are again extending this. So for empty cells, we don't need to do anything because this cell is containing two parameter flag. One is just this cell. Sorry. I'm just a little bit getting confused. But this line number 5 is going to tell us that whether that particular cell is flagged by the player or not. Okay. And this parameter, this variable is just holding the information whether that particular cell is revealed or not. Okay. Now by using that abstract class, we have created this mind cell and this empty cell. Okay. This mile cell, okay, we have not done anything much here. We have just override the reveal function here. Okay, so whenever someone call the dot reveal on this particular cell, we are just saying that hey, reveal this cell. Okay, here we can add more logics related to the game over mode, for example, whatever we want to do here. Like whenever the mind cell is revealed, we need to end the game and all those things that we will cover again in the further classes. In empty cell, if you see what we are doing in the empty cell, first we are marking it that hey, that particular cell is revealed, and then we are checking this adjacent cell. So now you must be thinking that hey, how we are finding it out whether we need to reveal the cells which are surrounded by an empty cell or not. For example, this one. Okay, so what we are doing is we have pre-calculated all those stuff already in the board. If you see this adjacent mine in this class, which is empty cell extending the cell class, we are having this variable called adjacent mine where we have already pre-processed all those things while we were initializing the board. Okay, so now we already know whether that particular empty cell have any adjacent things or not, basically. Okay, so here we are already storing that whether that particular cell is an empty cell or a number cell. So if you remember, we have discussed that we can have two different cells. One is the empty cell, other cell are number cells. Okay, here if adjacent mine count is 0, that means it is what? It is an empty cell. Then we need to trigger what? A flood fill strategy. If you remember, the flood fill strategy was to make sure that we reveal all the adjacent cells which are not mines. And if it is not, if the number of the count of the adjacent mine is not 0, that means it contains some mines which will automatically get revealed to the user. Okay, so that's how uh, we are using this empty cell for two purpose. One is for the empty cell and other one is for the number cell. Okay, I think we have covered. These two are just simple getters and setters. Maybe you can even use the Lombok for those things. Now let's come to the cell factory. As we have just seen that we have created the class for mine cell and empty cell. Okay, so here we are just having a factory pattern by which through which we can just call and to create the instance of those kind of cells. Let's move on to the next one. Simple observer pattern which we have implemented. This will be implemented by this game view class. Okay, so if you see here, what is this? This game board. What we are trying to do here is whenever there is a update um, on the game board, please notify this class. What is this here? This here will always represent to this class basically, which is a game view class. So what we are saying is that hey game board class, add me the game view class as a observer. So whenever there is a change on your side, please inform me. Please inform to this location. We are providing our location to them by passing this variable. Okay. Display mode, simple. We can just write our logic how we want to display it. Simple system not println, or if we want to use some other rendering UI engines, maybe OpenGI, something like that you can do here. Okay. This is we have not completed this code, but this is just an update function. So if you want to update anything in the game state, or maybe you want to update the score, we have not added the game score thing in the entire code, and we have not even discussed much about it. But that is what we will you will have to do in the update part for sure. Okay, like updating the scores of the player, or maybe providing them some other hints or the information. That is what you will have to do in this function specifically. Let's come back to the command pattern. So here we are just simply basic way of implementing the command pattern. We have created an interface with the execute function. Here if you see, we have two classes which are implementing that command class or the pattern. One is this reveal cell. So for example, if user have given the input that hey reveal the cell. So what we actually need to do here, which we have implemented here basically. Hey, go to game controller and go to this reveal cell and reveal this particular cell, this row and column. This input row and column will be coming from the user itself. Okay, the user will be providing these values. The users will be telling that hey, reveal the cell at 1, 1. So if you see in the output here, reveal cell at 1, 1. So user is saying, hey, please reveal the cell at 1, 1. That means, hey, call this reveal cell command with the input of 1, 1. We are providing the game controller, the game board, and that's how we are revealing it. Going to the flex cell, same thing. Nothing different. We are doing the same thing here. Instead of revealing the command, sorry, revealing the cell, we are flagging the cell. And what this flex cell is doing and the reveal cell is doing, and we have implemented in the game controller. Okay, that we will cover at the end. Let's now go to the reveal strategy. This reveal strategy is that flood fill strategy which we are going to use to uncover all these like 1, 2, 3, 4, all these cells which do not cover mines if a user click on a non-empty cell, something like this. Okay, here here we are implementing this flood fill strategy to make sure that we are revealing all the adjacent classes. Again, we have not implemented the DSLGO part of this class of this function, but yeah, okay. But this function is going to only reveal all the adjacent cells which are not mines. Okay. This is so let's first go to this. This is the game board. Okay, this game board is actually holding all the information about the current state. We are having one thing called game view. It is just a view what user is actually seeing in the front. This game board is actually holding all the data. Okay, so if you see here, we are having all the board information about the cells, the size, and everything. Here we are having the observer list. So whenever there is an update on the game board, these are the observers, or these are the classes, or these are the objects which we need to inform about the update. Okay, simple constructor here with the rows and mines. This will be called in this game controller function. You will see the number of mines we want to initialize. So this is how where we can play with that expert, beginner, and intermediate thing. Just for example's sake, here you can make sure like if it is a easy game, you will make sure to have a minimum number of mines. If it is intermediate, you will have a kind of maybe more mines. And in the expert, you will making sure that you can have highest number of mines, whatever we can have, making sure that the game is still playable, and basically you should be able to win that. There should be a way to win that game. Okay, here when I was telling you that hey, um, we are pre-processing the entire data. Here in this function, we are placing the mines. Okay, here you can use the strategy which I was discussing, that we can use the strategy pattern to place the mines on the entire board. For now, we are not using any strategy. We are just going with the basic way of placing the mines. After placing the mines, then we are calculating for every cell that hey, how many adjacent mines they are having, which I told you in the, if you go to this empty cell, it contains this one, now adjacent cell, adjacent mines. So this data of this is calculated here in this calculate adjacent mines. Okay, here if you see here, so what we are doing here is simple thing which we do. For every cell, we are checking all the 8 cells which are surrounded to that class, and then we are basically calculating how many adjacent mines are there. Okay, this can be definitely improved by a huge margin. As you can see, it's a kind of an square. Okay, although it's not, sorry, it's not n to the power 4 exactly, because this this n square is exact going to be kind of only 8 operations at max every time. Okay, but still, okay, 8 or 6, something like that. But still, we can definitely improve it by a good margin. Okay, and in the placing, if you see, the way we are placing is this one. We are using this random class again to find out. First, we find the random row and then random column, and we place the particular cell there. Okay, so that's how we are actually doing it. Here we are first uh, placing the mine on that particular location here. This true means, uh, if I go there, I'll show you dot create cell. Let's go to the cell factory is mine. Okay, when you say this is true, we are getting the mine cell. That's how it is working. And this one, okay, so once we have placed all the mines, then we are doing here. Then what we are doing is we are placing all those cells which are not mine to the empty cells, basically this is, you can even say that hey, this is not just placing mines, this is more about placing mines and empty cells. Okay, because when we were initializing it here, we have not initialized anything here. We have just created a basic 2D array here. At this, in this place mine, which I have just now changed to place mines and empty cells. Now it is actually creating the entire board for us. And once the entire board of empty cell and mine cell is created, then we are using this function called calculate adjacent mines to fill all those cells which to the number cells, like these number cells. Okay, this is done by this calculate addition, which we have just discussed, basically. Okay. Revealing the cell, as we were calling this function in the command pattern, this actually goes and reveal that cell. Okay. First, basic check, basic sanity check, making sure that the game is not over, making sure that this is not already revealed, and if everything is fine, we are basically doing this. If you remember, we what does this is reveal do? This convert that reveal cell variable to true in that those cells. Basically, if you go here, here in this cell, here this, sorry, yeah, this cell is marked true. Okay, by default they are always false. Okay, so this is what it actually do. Where it went here, that's one. Okay. And after that, it checks whether it's a mine cell or it's an empty cell by checking the class instance. If it is an instance of mine class, great, we got that a game is over, now you are done. And we notify all the observers about that. Okay. that something has changed. We can make it more granular level, what have actually changed. If we don't want to um, um, pass every information, we can have a granular level of observations where you can even have a category of the observers that hey, these kind of updates only need to go to those classes and all that thing. You can do more granular observations, or we can use observer pattern with a more granular focus, making sure that we are not calling something um, any class without the need. Basically, maybe they don't need to have that update because since we are not providing them any specificity of the events which we are going to pass to them. They have to just register there, so they will get all the events. We can definitely improve that part if you want to. Flag again the same way. First sanity check is done, basic sanity check. Then is flag again will do the same thing. Like is reveal is setting the reveal variable to true. Flag will also do the same thing, and then again same thing. Notify observer we are doing. Simple part of the observer pattern. Notify again the simple part of the observer pattern. Simple kind of a getter and setter. Okay. So I think we have covered everything here now. Let's come to game controller. We are using singleton pattern here if you see here. Okay. Here if you see, we are using the singleton pattern here to get the instance of n class. And here where we have written our main logic of the code and basically this one. The reason why this is not why it is written in this way, just to showcase you the how we can test this code. Otherwise, you will find the true here, and then you keep asking the user inputs, and based on the user input, you process. So instead of taking this predefined input here, you will be take user inputs here. Okay, and then you basically get the user input. You do this command pen, and then everything keeps going on. So here, if we see, once we get the user input from the user, we pass the data from them basically, which is nothing basically other than the row and column. Okay. So once we have got that part, then we are checking whether the command is equivalent to R or not. Okay. So when user will provide you the input or will provide you the instruction, it will provide you three things. Hey, are we looking to reveal the command or reveal the cell, or are we looking to flag the cell? Whatever it is, and what are the row and columns value for them. Okay, so based on this, we are checking whether it's a reveal command um, or the again flag command, and based on that, then as we have discussed about those classes and the pattern, they will just execute those commands in the game board. Okay, yeah, just a simple check if the game is done and all that thing. And this we have only specifically only done to have the to make show you how we can to showcase you just the sample output of this code. Okay, more basically you will write true here or some other way to kind of interrupt the game. That's how you normally do it. Reveal cell, flag cell. Okay, if I've left anything or not, I'm just trying to find that out. One more thing, if I want to tell you, so this game controller is working as a kind of a centralized class here. Every event is going through this one. Even for example, when you say that this reveal cell, okay, when you call this reveal cell command, if you go to reveal cell command, this is actually calling the game controller dot reveal cell, which is actually this one. When you call this game controller reveal cell, it actually calls the game board reveal cell, and it actually calls the this one basically. Okay, so that's how it is actually working. So everything is centralized to the singleton class, which is a game controller class. Okay, so that is what we are doing here. I'm just checking if there is anything left, which we have not covered. Okay, so this class is nothing which I was telling you know that I have specifically added this class just to showcase you how we can how that the output of this code. So this code is nothing more than that. So nothing else is there. I think we have covered everything mostly from here. We can move to the other parts now. And definitely we can do ton of optimizations here. Okay, we will see. Incomplete game over handling current implementation. If a mine is revealed, then the game is set over, but there is no mechanism to reveal the mine and provide. Yeah, so this is one of the things. So what is happening currently? Whenever someone click a mine cell, we are just saying, "Hey, game is over." Normally, what happens in the game when you click on mine cell, all the cells of those of the board are revealed to showcase the user that this is how actually the board look like. This is what we are trying to say. If the game mine is revealed, game is set to over, but there is no mechanism to reveal all the mine cells correctly. Right now, our current implementation, there is no way right now. Okay, so that is what definitely we can improve. That is what even normally happens in the game, at least on these kind of board kind of games. Okay. Other thing is this one, which is basically revealing the adjacent cell logic. So what you're trying to say is this flood fill strategy is not correctly accessing the game board. And currently, one of the thing is, as you have seen, we have not implemented the flood fill logic properly. Actually, we have not implemented it at all. So that is what one of the point we are saying here. That is what needs to be improved. And other way is the way it is actually getting the access to the cell coordinates and the game board. That is also actually needs to be improved. The way it is actually accessing the game that entire cell coordinates and the game board, that is definitely needs to be improved. That's not a correct way to access the game board. Scalability issue. So that design may not scale well if the large board. I think we have discussed it during the explanation also. If the game board is very very large, then there may be a issue because of this flood fill logic, which I was saying that the normal time complexity is to the n to the power 4, but actually it was kind of n to the power square. But still, it is not um, it is definitely going to be a bottleneck if we are having a very scalable, if you are having high number of the users, or sorry, if you are having a very large node. Okay, so we need to make sure that we are improving that. Again, definitely single threaded implementation is definitely there, so we need to make sure that the things work perfectly on the I mean, currently it does not, we are not actually utilizing the multi-threading things. So in this game, if you see, even in the all these things, if the animations, all these things can't be handled the way we are currently implementing these animation, the rendering of the board, the other calculations and all those things. So we need to make sure that we are making our design to work perfectly in the concurrent environment. It should not be just a single threaded code. So we need to make sure that we are utilizing the resources properly so that animations and other scenarios work properly. Other thing is, yeah, I think we have discussed this in the beginning also, that a game can have three levels: easy, difficult, and medium. Currently, we are not providing any way to the users to decide which gameplay they want to have. And after that, we have another problem of making sure that the mines which we are placing are according to the difficulty level. So for that, we will have to implement the strategy pattern, which we have not done yet in this current implementation. Okay. um, Same thing which you are discussing last also. Again, if user want to say that, hey, I just want to save the game and want to play this entire game later on. Currently, there is no functionality to save and load the game, and there is no basically user cannot resume the game later. There is no way of saving the state. Okay. Another thing is enhancing the user feedback. One thing is for sure there, displaying the hint or the tips. If you have played this Minesweeper game, you must have seen that sometimes in between it displays the hints or tips to the new players, for the new players, if you are a beginner player. So you can understand how the game works. So definitely that is missing. And that is not just a very simple, I mean, it's not just a very small thing. When you are providing the hints and the tips, you need to make sure that you are providing the hints and tips based on the current state of the game. So again, it requires a good amount of processing and the idea of the current state. And based on that, we need to decide what hints or the tips we need to give at that moment to the players. Okay. And again, providing the detailed feedback to the users about regarding the number of the remaining mines and the timers and the move counter. This is not, I would say, very critical functionality here. I mean, this which will not add much to the thing, but yeah, that is what also you can add. But I think this hints and all the tips, it's are really good for the user experiences. If you are playing a game, if you are new to the game, definitely you need some tips and hints in between, so you can learn the game smoothly. Last part again, which you are discussing multiple things. If you want, what if we want to have the multi-board support? What if we want to create a online Minesweeper where user will have multi. I mean, I can play the game, then someone else can play the game at the same point of time. So it should definitely have a multi-board support. Um, all those things we are already covering in our premium course. Okay. Um, Let me check if we are missing out something. Uh, um, this is just a sequence diagram. I think we have already covered it. You guys can definitely go through this sequence diagram, this one, offline if you want to. And yeah, I think we have covered everything here. I don't see anything is got missed. Yeah, I think for today, I think we are done.